The goal is to solve important spine and brain problems with a seamlessly implanted device.
Once you have a computer in your brain, your eyeballs are video cameras.
All of a sudden, every piece of information on the internet becomes accessible to our minds.
This is the RatBot, or the RoboRat. It's got technology, it's got electrodes going into its left and right hemispheres. The scientists can make this creature go left, right. They have it running through mazes, controlling where it's going. They've now created an organic robot.
You can solve everything from memory loss, hearing loss, blindness, paralysis, depression, insomnia, strokes, brain damage. These can all be solved with an implantable neural link.
We will be able to transfer memories. Knowledge will be commoditized. All of us will be smarter.
Most people don't really understand how this technology works, what data is collected, how it's stored, or who might be able to get access to it legally or illegally.
The human brain is the most powerful supercomputer in the world.
All right, let's see this electrical headquarters of yours in operation.
It helps us navigate our environment by carrying out about 1,000 trillion logical operations per second. It's compact, uses less power than a light bulb, and has potentially endless storage.
The human brain is really one of the most complex systems that we can imagine.
We have a fundamental lack in our understanding of the way the components in the brain interact. But it is this very interaction that generates cognition and consciousness.
The brain is packed with neuron cells that constantly communicate with each other through electrical pulses, known as spikes. Each neuron releases molecules that act as messengers and control if the electrical pulse is passed along the chain. This relay race is happening simultaneously throughout billions of neurons. Much like the zeros and ones of the computer world, this is the basic language of the brain. But understanding all of this isn't enough. We've still only scratched the surface when it comes to figuring out how the brain works. Professor Amunds and her team are working on one part of it, a 3D digital brain atlas. They're creating 3 different high-resolution maps. One of neurons, one of their connections, which uses different colours to indicate the orientation of neurons' branches, and one map of the receptors for the messenger molecules.
There is not one single aspect that can explain everything in the human brain. So that means we need different types of maps that reflect different aspects of brain organization.
To create the maps, the team is scanning slices of post-mortem brains.
We get brains from body donors and process them, embed them in paraffin, and then cut them into 20 micrometer thick sections. 20 micrometers, this is approximately like thickness of one hair, so this is very thin. One brain has approximately 7,000 sections. These sections can then be analyzed under the microscope, and we can then reconstruct the areas in 3D.
Much like a fingerprint, every brain is unique. So to account for these differences, the team scanned 10 brains for each of their maps.
Is building so-called dish brain chip. They grow a group of neurons, so brain cells, in the lab, and then they incorporate it into a computer chip. And it works because both computer chips and neurons communicate with electrical pulses.
The past 20 years have been focusing on the intense work of neuroscientists, which resulted in a revolutionary technology known as BrainGate. And the main goal is to connect the human brain to computers through BCIs, brain-computer interfaces, or BMIs, brain-machine interfaces. These brain chip implants are tiny processors that connect to your brain through threads that are significantly thinner than a human hair. In other words, as your brain is linked to a computer, all your data, such as memories or health information, will be continuously communicated back and forth.
We'll not only be able to transfer knowledge, but we will be able to transfer memories. Now, so you could have an experience like skydiving, and all of a sudden you could transfer that experience to a friend. and all of a sudden they have experienced what you have experienced.
In a recent conference, tech mogul Elon Musk talked about his latest innovation, a brain chip implant that could allow people struggling with paralysis to use technology, like smartphones or robotic limbs, with just their thoughts.
We will have brain chips in humans. And the people who will get those brain chips first are people who suffer from severe medical conditions. So if you have a severe medical condition, like you're paralyzed from the neck down, or you suffer a brain disorder like Alzheimer's disease or Parkinson's disease, and that brain chip can restore your quality of life, would you hesitate to get the chip? No, of course not. You would say, put the chip in my brain. So that is starting right now, these experiments.
However, not only disabled people can use such brain chips. Connecting a healthy human brain to a computer can help the individual to use its abilities to the fullest by enhancing senses, physical movement, and the ability to memorize. Could you imagine using Facebook without typing? Or maybe driving your Tesla with only the power of your mind?
Because our senses now, we have our 5 senses of our body. But suddenly, if we are connected to a world of intelligent machines and intelligent sensors all over, we will no longer have 5 senses. We will have access to hundreds of sensory input, infrared, right? All these UV, all these different types of senses that we never even experienced before. It will radically change how we perceive existence.
And the possibilities of implanting brain chips are both exciting and frightening. It is a matter of choosing how much we are willing to share of ourselves with a machine. It can be a real relief to communicate with others only through your thoughts. Sometimes we can find it difficult to express what we're thinking about, so having others read our mind could be useful. Yet would you sleep well at night knowing that others have the ability to access your mind?
So there will come a point where if we have a chip in our brain, and you out there have a chip in your brain, we can communicate. We can communicate without talking. We can communicate when you're halfway around the world. And we can exchange knowledge.
It can be really fascinating to control a light switch or to drive your car with just your mind. But would you feel comfortable knowing that others can control your thoughts? This may sound like a science fiction movie script, but things are evolving precisely towards this direction. Having the ability to access the human brain and to understand how it functions, while connecting it to external devices, can bring along numerous resources. It is especially useful for people dealing with severe neurological damages. Yet there are also several worrisome possibilities that are thought to cause harm. While the idea of having a perfect memory sounds really amazing, the fact that this perfect memory could be hacked sounds terrifying. Imagine that some of your most precious memories could be shared with other people.
Because we will be living our lives as our lives. We know our lives and our memories. But you will all of a sudden have access to anybody's life who wants to make it available to you. People will open source their lives so others can download pieces of their lives and experience those things. That will be really strange. We won't know the difference between our own memory and a memory we acquired from someone else. Think about that.
To scientist Greg Braden, not only that inserting brain chips can be destructive because they can interfere with the normal functioning of neurological processes, it is also unnecessary. What these brain implants are thought to help us do, we already possess the biology to do it on our own.
Mirror neurons are a specialized class of neurons in the human brain that don't know the difference between watching an experience and having the experience. This is why you can lie on your couch on a Sunday afternoon watching a soccer game or a golf tournament or whatever. You're lying down, but you're watching this and your heart's racing, your muscles are tense, you might be perspiring, you might be, breathing heavy, but you're just lying there. I mean, if you think about that, it makes no sense. Your mirror neurons think you're the one on the field because the brain doesn't know the difference between watching and having the experience.
The difference between us dreaming and reality will be blurred. We will be spending a lot of time outside our bodies. So, think about this. You, as a human being right now, are trapped in this body. But once you are connected to the internet, you are no longer trapped in your body. You can actually be anywhere at any time that any other person or any other device is getting sensory information.
When we learn to access these mirror neurons in a very specific way, we have super learning. I do this personally. I mean, we can learn very, very quickly. We can learn music. You can learn to perform the way another musician is performing. You can learn a foreign language very quickly. You can retain, not only retain, but recall information. Super learning, super memory, super retention, super recall.
Brain chip implants can indeed create numerous opportunities for the disabled. But for those of us who are healthy, there are several questions to answer.